Okay, so we are solving quadratic, we're going to talk about that word, equations by factoring. Okay, and this learning target is kind of made up of 3 separate parts. Solving equations, which you know how to do. Factoring, which I taught you, you should know how to do. And we got to kind of take a look at this word again. All right, we've seen this word before. We've seen it in Unit 7 when we classified polynomials, right? It was that one that was kind of cruel because quad usually means 4. So what does quadratic mean to you? It means an equation that's highest exponent, yes, is 2. So a degree of 2 is a quadratic. So, in other words, like x squared minus 3x plus 4, that is a quadratic equation. You have been factoring quadratic equations for weeks now, right? Wasn't all of the ones you factored, the highest exponent was a 2? Or if it wasn't, when you pulled the GCF out, it was a 2? So we've been dealing with quadratics for a long time now, okay? A couple weeks now. And what we're going to get back into, not today but tomorrow, is I call this the sister unit, or the sister chapter for Unit 4, where we dealt with linear. So do you remember what linear meant? What was the highest exponent in a linear? It had a degree of what? It's good studying for the final. 1, right? So like y equaled 2x minus 5, that was linear because the highest degree, was a 1, right? Don't put a 1 there. So we spent all of, second trimester really getting ourselves acquainted with linear equations. And linear means when we graphed it, it was a straight line, right? So when we went and graphed y equals x, it was a straight line, wasn't it? Okay? And man, we learned a lot about that line, right? We learned what made that line flip upside down, right? By putting a negative. We learned what took that line and made it shift up and down. So it was like your x minus 4. Okay? So if we started with the blue line, we shifted it down, we turned it around, we made it steeper, right? We took that y and we put a number in front or a coefficient in front of that x, and then it got steeper. We changed it, instead of putting a 2 in front, we put a 1/3 in front, and we didn't make it steeper, we made it less steep. Like, you learned a lot about a silly old line. Did you ever think there was that much to learn about lines? Okay? So, all these different lines were created based on what you did to that x. You either made it negative, or you put a number after it, or you put a number in front of it that was greater than 1, or one that was less than 1. So, guess what we're doing in Unit 8? The exact same thing, except not with a line. So let's go erase all these. And just as well as you know what a straight line does, we're going to get to know what x squared does. So not linear, but quadratics. So here is the shape that you are going to learn to love. That is our new shape. Meet the parabola. All right? If you could picture, they can animate things, picture little eyeballs and cute little eyelashes on it. This is a parabola, and it's your best friend for the next 8 days, okay? You're going to learn all kinds of things about what makes it move around, what makes it skinnier and narrower, what makes it wider, what makes it flip upside down. So all of these things that we're going to do, and here's the really awesome part. The awesome part about all the things that you can do to this parabola is that it's kind of the same things that you do to the line. So I take this and I can do, I can move it around. I can make it go over that way. I can make it even go left and right. Oh, let's say my battery on this calculator is close to being dead. So there's the parent function of it. There we go. You know, and then we're going to take it and move it to the right. That one is moved down. Okay. So there's all kinds of things that we're going to do with this. And your mission in the next 8 days is to really get as familiar with these things as possible. Let's talk about this too. Let's get rid of that one. Let's get rid of that one. Let's make this a 4x squared and see what that does to it. So this is called my parent function, just like the other line was, and then this is 4x squared. You would think so, wouldn't you? But it's the opposite, so that's 4x squared, so it got narrower. So basically, this is me trying to say to you, there's a lot that goes on with quadratics, and we're going to learn about that. So we're pretty good on linear. Do you feel like you know all there is to really know about mastery of linear functions? So I want you to put the word non-linear here. Means for the first time all year long, we're seeing something that is not a straight line, okay? All right, so let's dive right into this shape here. And it starts like this. This is our first example. You have x squared plus 4x plus 3, okay? If that was the problem that I gave you last week, all you did was factor it, right? But there's one little difference here with Unit 8 and with Unit 7. Unit 7, we just factored. Unit 8, we're solving equations by factoring. But you can't have an equation without what? An equal sign. Okay? So the first thing you're going to do is make sure that all of your terms are on one side of the equation and a 0 is on the other. Doesn't matter if the 0 is to the left or to the right, and you want it in standard form. 2, 1, none, right? Okay? So here's the really cool part about this. When I'm doing Unit 8, I'm assuming that I already taught you the factoring unit. So I'm going to kind of cruise through the factoring part of it, okay? This will be a great review for those of you who are planning on retaking that last test, right? So here we go. There is not a coefficient that's not 1. So to get x squared, I did x times x, right? And for those of you who really like to kind of stick with your routine, you can go ahead and do your x. Some of you don't need the x. But your x, remember, is your a times your c, and then your b goes down here. My a times my c is just the 3. So when that's just a 1, it's just 3. So I'm looking for two numbers that when I multiply them give me 3. When I add them, gives me 4. Yeah, 3 is prime. You only have two choices, right? It's 1 and 3. Because 1 times 3 is 3, 1 plus 3 is 4. And they're both positive, right? So I started you out pretty easy. Plus 3, plus 1. Okay? Now, if that equals 0 wasn't there, you'd be done, right? That was an answer on last week's test, right? But because that equals 0 is there, we got to take it one step further. So in order to do today's, you have to know how to factor and then go a little further with it. So we're going to talk about finding the zeros. And it really builds off a concept that you learned in 3rd grade. When you learned in 3rd grade that you had a number times another number, if the answer or the product rather was 0, what did you know about one or both of its factors? One of them has to be 0. That's the only way to get a product of 0, is if either one of them or both of them are 0. So I want you to look at this. What this is telling you is that x plus 3 is one factor, x minus 1 is another factor, and the answer is 0 when I multiply these together. So what this is telling you is, okay, what would x need to be in this parentheses to make that parenthesis equal to 0? What would x need to be to cancel out that plus 3? Negative 3, right? What would x need to be in this parenthesis to make this parenthesis equal to 0? -1, right? Those are my zeros, okay? We're going to talk more about what zeros are. We got to talk a little bit more about this too. So x could be -3 or x could be -1. You're going to have two answers, okay, at least for this one. So what that means is this. These are called your zeros, but you'll also hear them called your roots. We're going to talk about what that means in relation to we're going to talk about what that means in relation to this graph. What are roots? What are zeros? Remember how I said, oh, y-intercept. If I said y-intercept, you knew right away, oh, look at the y-axis at -5, right? So those roots are going to be your big keywords as well. So the first thing you need to understand is that you have two numbers, but you will never write these as an ordered pair, right? So you are allowed to keep your answers like this. You are allowed to write your answers like that. You are even allowed to write your answers like that because those are called braces that represent a set of numbers. When you have braces, it means the numbers inside are a set of numbers. And this set represents all the numbers that x could equal to make that equation 0. Okay? This is the only way you cannot write it. Why can you not write your zeros that way? Because that's an ordered pair. And to me, that means -3, -1, and that's what that point tells me. And that's not what those are. I'm about to show you what these are. Okay? So here's the pretty cool part about, we're going to slowly work our way up to getting comfortable with this thing called a parabola. So let's take a look at this. And it's actually pretty simple. What your zeros are is where your parabola, so I got an x, I'm going to go to the x-axis at -3 and put a point. I'm going to go to the x-axis at -1 and put a point. And what do you think those are? If you're looking at this shape. I mean, you could take that shape and move it around. That's where the parabola is going to cross the x-axis at. Okay? So then somebody said, but right now, that's all I know about it. I don't know anything else about this parabola. Somebody said, we're going to talk about something called a vertex too. The vertex of a parabola is going to be the highest or the lowest point of the parabola. Okay? So, it sounded like a shriek, didn't it? That was creepy. Okay, I thought it was a police car. It was a goose? Is that a goose in pain? Or something? Okay. What is it? Oh, okay. All right. So right now, that's all the zeros tell me. It doesn't tell me anything else about that. We'll learn about that stuff tomorrow. Today, all I want to know is if you can find the zeros. So you know what? If the vertex is here, then there's my parabola. Maybe it's not there. Maybe it's way down here. And if it's way down here, then the parabola will go like this and be real skinny, right? So right now, zeros only give you where that parabola is going to touch the x-axis at, okay? So it's kind of like you can call them the x-intercepts, could you? Okay? So you know what a y-intercept does. These are your, I guess you could call them x-intercepts, where the parabola, weird word, I know, will cross the x-axis, not the y. It's where the parabola will cross the x-axis, okay? And right now, the vertex is still unknown. Don't know anything about it yet. We will learn about that tomorrow, though. Okay, so, yes. Yes. Mm-hmm. Yeah. It will use the word intersects. Yeah, crosses, intersects, meets, all that stuff. Okay, so let's do another example. Let's take a squared plus 6a plus 8 and have it equal to 0. So, first thing I'm going to do is get it ready to factor. Don't forget your equals 0. Still kind of lucky because my coefficient is 1, which means it's one of those real quick and easy ones, because the only way to get a squared is an a times an a. If you want to do your x, go ahead. You have 1, so I'm looking for 2 numbers that multiply to give me 8. Yep, add to give me 6. Pretty easy one. Positive 4, positive 2. And when I know that there is no coefficient there, I can take them right from the x and place them, right? I can't always do that though, right? I'm going to tell you when you can't. So now I have to, oh, and here's another thing. You're going to have to show this, because some people look at this and say, oh gosh, shoot, how do I know which one is which? So here's what you're going to do. You're going to take each parenthesis and create a mini equation from it, because I want to show you how you can come up with that without having to think too hard. So take your a plus 4 and set it equal to 0. Take your a plus 2 and set it equal to 0, and then solve, which means that's why that 4 becomes negative, and that's why that 2 becomes negative. So my zeros are, and I know there's an a there. It could be a y. It could be an x. It could be a w. It could be whatever. It's kind of confusing when it's a y, though, because you're thinking y-axis. But these are always x-intercepts. Yes, JC.
Later on, are we going to get to an equation where there's a coefficient?
Yep. Right, yep. As soon as I'm done with this next one, yeah. Okay? Okay, so be careful, because I want you to see what would happen if you had this problem. Okay? So the first thing I said to you is, in order to factor, they have to all be on the same side and in standard form, right? So before I can actually start to do the problem, I have to do a little cleaning it up. Okay? You always want to make sure that your leading coefficient is positive. So this is staying put. This has got to come over to it. So what do I do to get it in standard form? I got to get rid of it on that side and put it over here, right? So what that means is now I have y squared minus 7y minus 18 equals 0. Okay? So just got to move a few things around. So you're going to move around your terms to get it in standard form is what you need, right? Okay. Once I have it in standard form, factor it. And we still have a coefficient of 1, so we're styling, we're good. Y squared is y times y. Okay, for those of you who want to use the X box, your product is a negative 18. Your sum is a negative 7. So the first thing you need to know is that you have 1 of each. And here's another advice. I've had more people, I'm kind of surprised, come up to me and say, I just can't think of the numbers. I don't know what the numbers are. And that's the case when they get bigger. Like if you have 48 has a ton of factors. So you know what you may have to do? You may have to sit and list them all, I guess. 1 times 18, 2 times 9, 3 times 6, and then step back and look at them. Which pair is going to give me a difference of 7? Right. So some of you are able to come up with those numbers quickly in your head. If you can't, then do that. So which one needs to be positive, which one needs to be negative if I want a sum of negative 7? Do you see how this is a great test reflection for those of you who are going to retest? Like, I'm doing everything on the test for you. So this 9 has to be, and so then I can take these 2 and put them right into the parenthesis, but only because that is a 1. Okay, we're going to do it when it's not. I'm not done yet, because I still need to do y plus 2 equals 0, y minus 9 equals 0. And I know what you're thinking, oh my gosh, do I have to show that? That's so annoying. Can I just know that it's a negative 2 and a positive 9? Eventually, I will let you just go ahead and do that. But you're going to see why in a minute. And JC asked it. So I know it says y. That's why, I don't know, the computer program I used to make these, use other variables besides x. Just know that those are your zeros. And up here I didn't, you are not going to have to do this, but what this means is that you have the parabola that crosses at -2 and -4, but right now that's all I know. Okay? So up here I have a parabola that's going to cross at -2 and +9. And somebody said, well, that's going to be a wide one. And I said, well, maybe. If your vertex is right here, heck yeah, that's going to be a super wide parabola. But what if your vertex is way down here? Right? So it has everything to do with where is the vertex. And that's going to be tomorrow. We're going to figure that out. So we don't know anything else about this shape except where it's touching the x-axis. Yeah?
What if, like, the y plus 2, y minus 9, the
The numbers what?
Or, wait, no.
Numbers for, yeah.
Okay, no.
Okay, did you answer it in your own head?
Yeah.
Yeah, okay.
If it was like a positive and a positive,
Then they would just be they would just be two negatives. So if that was, say that again, like a positive and a positive up here. Okay, I guess does anybody know what he's talking about?
So like,
If it was +2 and +9.
or no.
Okay, all right. If it comes to you, let me know because I want to be able to help. Okay, are we good on this so far? All right, because now we have to talk about what happens when we get to this problem. 3n squared plus 14n minus 5 equals 0. You know what? No big deal. That's okay. There's a coefficient there. It just means instead of just the x, we have to do the x and the box, right? So let's start by factoring right away. Here's the good news. 3 is prime. So instead of just n times n, I know it's going to be a 3n times n. You don't have to fill that out right now. But let's do the x and the box. This time my x is a times c, which is -15. And b is 14. Well, that one's pretty easy. Okay. A negative product means a positive times a negative, right? It's going to be 15 and 1. Positive 15, -1. Now stop. You cannot just take these two and put them there, right? Because that 3 is a game changer. If that was an n, go for it, and then you'd be done. So you know what you got to do? Yes. But that's okay, because we can fly through this box, right? So, perfect review. Do you know what to put here? The 3n squared and the -5 from your equation go here. Yes. And then these go here. What do you mean? Oh, no. We just trial and errored it. We always just did a trial and error for years and years and years, and it was a pain in the butt. So GCF of the first column, GCF of the first row. So this is n, and this is 3n. Right? That's how you check it, which there it is, which I knew it was going to be that. And then remember, these terms have to be positive, right? I have some people who are pulling negatives out. Then let's fill it in. 3n times what is 15n? 5. n times what is -1n? So I had to go through all this just to factor it. So this is n plus, we still have to find the zeros. And this all equals 0. Okay. So this brings up, I think JC asked it, right? Yeah. Well, what do we do when there is a coefficient there? Well, I know that's going to be -5, right? Because here's why. I have n plus 5 equals 0. 3n minus 1 equals 0. And this is why it's important to know that you set each up in equal to 0. So stop for a minute. And I know you guys can, this one's -5, right? So one of my zeros is -5. Okay. To make this parenthesis equal to 0, I have to find this number and subtract 1 from it. So this needs to equal 1. What could I multiply 3 by to make it equal 1? It almost sounds like a trick question. 3 times what is equal to 1? Allie? 1/3. Right? Right? So that's going to be your 0. But look, you're going to figure out a shortcut, but I'm not going to tell it to you. So add 1 here So it's always the opposite sign of what you're looking at, right? So if that was a negative, it's going to be positive. If that was a positive, it'll be a negative. And then, yes, if this was just n would equal 1, but there's a 3 there. So it's going to be 1/3. So it's going to be the opposite of that over that, basically. Okay? So your zeros then are going to be -5 and 1/3. Right? That's all you know right now. Okay, so far? All right, I'm going to show you 2 more examples, and then you're going to be done. That's all you're doing is finding the zeros. But there's a couple things I need to remind you of. 2x squared plus 12x plus 18. What do you have to do? What I should have been saying it the other times. Do what first before anything else? Before even factoring. Yes. Look for a GCF, and it's 2. So that's going to give me x squared plus 6x plus 9. And then the next thing I ask myself is, remember that? What's up behind the board right now? Are those perfect squares? They are. Oh. Are there 2 terms or 3? 3. So that's going to look like that. The square root of x squared is x. The square root of 9 is 3. Whatever sign is here goes there. And this brings up a really interesting question. First of all, this GCF, remember how it was like super important? You have to have it in your answer. I don't care about it right now when finding my zeros. I just needed to pull it out. But I have 2 of the exact same parentheses. Oh, I would love it if you could explain to me what this means, because of all the other problems we've done, we've had 2 zeros. So here x equals -3. Here x also equals -3. I thought you had to have 2 zeros. No, your parabola can be anywhere it wants on that graph. What does just having 1 0 mean about that parabola? That must be if the only place that this parabola is touching that x-axis, that must be the vertex. That must be the high or the low, right? So it's either going like this or like this, but it's not crossing anywhere except, so it's literally like sitting like a little bird on a wire. It's perched right on the x-axis. Do you see what I mean? So when we get a special case like that, and it factors into the same one, it's physically sitting right there. If it was down a little bit, then it would have 2 zeros. Okay? Let's do another one. We're getting there. All right? So because of the way this factored, I had 2 identical parentheses, which means I had 2 -3s. You can't have 2 -3s. That's only one spot. So instead of it crossing in 2 different spots, it's sitting and resting right on the x-axis. That's all that means. Okay? All right, let's do another one so I can get you guys moving. So, how about -32y squared equals -72? This one just looks like a mess, doesn't it? It doesn't look like anything you're used to. It's got a negative leading coefficient, which we can't have. And it's a big number. Okay, so here's what I want to say to this. Remember how I said you can move them around however you want? I don't want to bring that 72 over here because that 32 is still negative. So what do you want to do with the 32? Bring it to the other side by adding 32y squared. Okay, so you know what? The zero's over here this time. So what? And then you have 32y squared minus 72. Okay, yes, and then you could, if it makes you feel better, you could put the 0 on the other side. Is there a GCF? Yes. 4y squared minus 9. Anybody recognize that? Are those perfect squares? Is that a minus? Are there 2 terms or 3? If there are 2, then that's the one where there's 2 parentheses. They're not identical because a 3 and a 3 don't cancel out. You have a 2y plus 3 and a 2y minus 3, correct? I don't really care about this. This doesn't affect my zeros. So I'm going to have a 2y plus 3 equal to 0, a 2y minus 3 equal to 0. Now I have to find my zeros. And to do that, you just solve each equation. So this one's going to give you a negative 1.5. And then as guessed, the other one will give you your positive 1.5, right? And so when with that, I know I'm fly through those because I know you guys know how to solve equations. So I have one here, and I have one here, and that's all I know about that. Okay? So how do you feel about this, Audrey?
What would happen to the equation if the parabola doesn't?
Yes. So for example, you will come across a parabola that's kind of out there floating in quadrant 1 somewhere. It just means that that would be not factorable. That would be you starting off with an equation and sitting there and going, oh my God, I'm trying to factor it, I can't factor it. Okay? Because there are no zeros, all right? So you're going to learn all these things about this awesome